You are listening to The Vocal Technologist. Spoken tech for your ears.
You know that feeling when you sit down at your terminal, take a sip of coffee, and suddenly it feels like the entire software engineering landscape just mutated overnight?
Oh, yeah. It's a very real feeling lately.
You are definitely not alone in that. So today's deep dive is absolutely for you. We are unpacking a massive stack of recent technical dispatches, raw developer data, and some really deep architectural teardowns.
Right, because we need to look at the inner mathematical workings of large language models, the whole trillion-dollar economic reality of this AI boom, and even get down into the weeds of specific React bugs and bizarre Git compiler quirks.
Yeah, the mission here is really to just cut through that relentless hype cycle. We want to map out the structural ways AI is fundamentally changing how software is built right now.
Exactly. But we're also analyzing the very real risks of, like, manual skill decay and highlighting those specific areas where human intuition and deep primitive system knowledge remain absolutely irreplaceable.
So to start, I was looking at Cursor's new developer habits report, and the headline metric just immediately resets the baseline for this entire conversation.
It really does. It's wild.
Yeah, coding speed has literally doubled year over year. I mean, developers are shipping significantly larger pull requests, and they are leaning incredibly hard on context and automation to do it.
But to really grasp what that actually means, we have to talk about the math driving all this raw output.
Yeah.
We hear the word tokens thrown around constantly.
Right.
Basically, the model converts raw text into subword tokens, which are then mapped to numerical vectors called embeddings. And those embeddings represent semantic meaning.
Okay, but that conversion is really just the starting point, right?
Yeah, exactly. When a model maps a token to an embedding, it's essentially placing that word into this high-dimensional mathematical space where words with similar meanings are physically closer together.
Which is fascinating, but isolated meaning isn't enough to actually write a functional script?
No, not at all. The system needs to track sequence. So positional encoding applies a distinct mathematical signature to each token based on its place in the prompt.
And then the attention mechanism takes over.
Right. It calculates a probability weight between every single token in the sequence.
Which means if you declare a variable at the top of a file, the attention mechanism is what allows the model to, assign a high mathematical weight to that specific variable name 50 lines later.
Exactly, when it actually needs to be called.
It's almost like a massive orchestra. Every token is an individual instrument, and the attention mechanism is how they listen to each other to, stay in harmony.
That's a great way to put it. But the scale of that calculation is just immense. This is where the transformer stack becomes super critical.
Right, because the architecture isn't just attention.
No, it relies heavily on feed-forward networks to process all those weights. And you have these crucial elements like residual connections and normalization layers.
And those residual connections basically act as bypass lanes, right? Allowing data to skip certain layers so the mathematical signal doesn't degrade over thousands of tokens.
Yeah, and then the normalization layers keep those massive vector calculations mathematically stable.
So the model doesn't just totally hallucinate halfway through writing a Python file.
Exactly. The mathematical stability is what makes the speed viable in the first place.
Right, because the logical assumption is that, doubling your coding speed with an AI just generates terrible, buggy code.
But the empirical data totally refutes that. There was this fascinating statistical analysis just run on 36 releases of the Earthsync utility.
Oh, I saw that. They used severity-weighted bug metrics and exact permutation tests to analyze the code bases.
Yeah, and the software versions that were assisted by Claude AI fell entirely within the normal historical distribution of bugs.
Wow. So they were not statistical outliers at all.
Not at all. So the output is fast, and it is remarkably stable.
But, and this is a big but, the dual-use nature of this technology is completely wild.
Oh, absolutely.
In an experiment on an intentionally vulnerable React Native and Python app, security researchers put up a $1,500 bounty to see if an LLM could break in.
And GPT 5.5 successfully exploited the vulnerabilities and hacked the app.
It's crazy. If we use that orchestra analogy, the AI is the conductor, the musician, and the threat actor trying to pick the lock on the concert hall door.
Yeah, which creates a really profound bottleneck. If a model like GPT 5.5 is generating massive, stable pull requests at double the speed, the system breaks down at the human interface.
Because our current IDEs were engineered for human typing speeds, right? And human cognitive loads.
Exactly. The sheer volume of tokens these agents output physically breaks traditional workflows.
And that friction is basically forcing the industry to invent an entirely new workspace. We're witnessing this massive shift from DX developer experience to AX agent experience.
Yes, agent experience is the new frontier. I was diving into that 8-stage context maturity model, and the numbers are just startling.
What were they, like 60%?
Yeah, AI is currently involved in 60% of engineering work, but we can only trust a fifth of it unsupervised.
And the bottleneck there seems to be how we use model context protocols, or MCPs, right?
Exactly. We use them to give an AI access to a tool, like the ability to execute a shell command, but we give it zero understanding of the environment it's actually operating in.
Because agents are inherently stateless. They don't retain memory between sessions unless you explicitly prompt them to.
Right, and they don't inherently understand the idiosyncratic state of your specific local machine.
So if you want an agent to be reliable, you must engineer a highly deterministic layer around it.
You have to provide scoped permissions and guaranteed context.
Like a tool such as Flux, for instance. I mean, why are we building this for AI? Because an agent has no idea if your local machine is running an outdated version of Node or some conflicting Python library.
Exactly. So Flux creates declarative, reproducible environments. It provides this hard-coded mathematical recipe for the environment, so the AI isn't just guessing which dependency to use.
It fundamentally eliminates the whole works on my machine error.
Because it completely removes the machine's unique state from the equation entirely.
And we're seeing an entire ecosystem being built around this principle. Like, look at MicroPython WASM.
Oh yeah, that provides a really secure WebAssembly sandbox.
Right, so if an agent hallucinates and tries to execute some destructive Python script, the WASM sandbox physically isolates that execution from the host operating system.
Or consider the desktop commander MCP, which explicitly structures how a model accesses the local file system.
You also have CodeWASM, right, which centralizes AI skill management across platforms like Claude Code and Cursor.
Yeah, and LaunchDarkly's code control, which allows for progressive feature rollouts basically at machine speed.
Okay, but I really have to push back on the philosophy behind this whole pivot.
How so?
Well, instead of building tools to make the human developer's life easier, it feels like we're essentially building luxury, highly deterministic apartments for our AI replacements.
I get that, but the customization is really a requirement of the token volume, not necessarily a replacement of the human.
Okay, fair.
When an agent moves into that deterministic environment, the operational paradigm just shifts. We're moving away from single agent generation toward a workflow called automated doubt.
Automated doubt, that completely changes the pipeline.
It really does. Instead of having one AI blindly write a script and push it, developers are deploying specialized subagents to constantly critique the work.
So during the design stage, you have agents specifically prompted to attack the architecture and look for hidden assumptions.
Exactly. And then post-development, a totally separate suite of agents audits the codebase for security flaws and type safety.
Open Code Review is a great example of this, actually.
Oh, for sure.
It's an AI-powered CLI tool that blends deterministic logic with dynamic agents to provide this incredibly precise, line-by-line git-diff feedback.
The challenge with automated doubt, though, is the financial overhead.
Oh, the token spend.
Yeah. Having multiple agents continuously reviewing expanding context windows is literally bankrupting some projects.
So the engineering solution to that is smart routing.
Right. Infrastructure is being built to dynamically analyze a task's complexity before execution.
So simple, repetitive tasks are routed to cheaper, smaller models.
While strict guardrails reserve the really expensive, frontier models solely for complex reasoning and critique.
And that workflow evolution is completely altering front-end design as well.
Yeah.
I mean, developers are skipping Figma entirely now.
Yeah, they're using Claude to code functional interactive prototypes directly in the codebase.
And the culture is adapting to this too. Developers are having fun with it, building tools like Performative UI, which is this React library that specifically mocks the super trendy, over-the-top design tropes of new AI startups.
Or Mitos, which generates ASCII art from custom JavaScript.
Right. The human pipeline of design, build, and test is kind of dissolving into this decentralized web of AI generation, continuously checked by AI critique.
But we have to talk about the psychological impact of that dissolution on the human software engineer, because it is severe.
Yeah, the burnout is real.
We're documenting significant burnout and career anxiety. Engineers who have spent a decade building incredibly specialized, granular debugging skills are just watching LLMs automate that entire process.
They feel their hard-earned intuition eroding.
Exactly.
It reminds me of the whole AI rockstar developer phenomenon. Like, if you are listening to this, you have definitely had to clean up after a human rockstar dev at some point.
Oh, absolutely. The person who wrote brilliant, overly clever, completely unmaintainable code and then just left the company.
Right. And now AI tools are doing that on an industrial scale. They rapidly produce massive amounts of fragmented code that solves the immediate ticket, but completely lacks any cohesive architectural vision.
And the human is left to clean up an exponentially larger mess.
Which ties into what the aviation industry calls the automation paradox.
Right. The better the autopilot, the worse the pilot.
Highly reliable automation paradoxically increases catastrophic safety risks because it breeds human complacency.
And causes manual skill decay. When the AI seamlessly handles 90% of the routine debugging, the human engineer loses the mental muscle memory required to solve the critical 10% when the system truly fails.
It feels exactly like how people completely lose their innate sense of direction when they rely exclusively on smartphone maps.
Yes.
We're essentially losing our internal GPS for the code base.
The smartphone map analogy is perfect for highlighting the complacency, but the stakes in software architecture are just so much higher.
Because if you miss a turn on a map, you just reroute.
Exactly. But if you lose your internal GPS in a massive code base, you might blindly approve an AI-generated architecture that subtly compromises your entire database schema.
And the technical debt compounds instantly.
Instantly.
Which brings up, honestly, the most counterintuitive survival strategy I found in all the research. The absolute necessity of doing nothing.
Yes, maintaining an 80% utilization rate.
Right. Because if you are operating at 100% capacity, just reviewing the sheer volume of AI output, you will burn out.
You have to leave a 20% buffer. It's the only way human engineers stay available to spot those unpredictable, high-impact architectural flaws.
The role is essentially elevating from a senior engineer who is focused on individual execution to more of a staff engineer mindset focused on multiplying team impact.
And a really critical skill in this era is wielding the maybe later feature strategy.
I love that.
Engineers have to actively choose not to build certain features because AI-generated technical debt is so cheap to create and so incredibly expensive to maintain.
And that restraint is where human precision becomes absolutely vital. Because despite the autopilot paradox, there are granular, deterministic realities of system architecture that AI just consistently stumbles over.
Because AI relies on a semantic approach, it understands the general vibe or meaning of a concept.
But software execution requires exact, primitive truth.
Exactly. This is why a basic grep, just a simple lexical search, often outperforms vector-based semantic search for long memory question answering in a codebase.
Because semantic embeddings smooth over the jagged edges of a code base.
Right. If you're tracking a deeply buried bug, you don't need a summary of the concepts. You need exact variable names, verbatim timestamp formats, and specific log syntax.
And lexical search catches those exact string matches perfectly.
So the determining factor for success isn't always the model's reasoning power, it's the agent harness, the specific tooling and search methodology we wrap around the model to retrieve that exact truth.
And those jagged edges are the deep system quirks that human engineers still have to navigate manually. Like, take React's use effect hook.
Oh, yeah.
An AI will often struggle to fix a looping effect because it hallucinates some complex state issue. But the underlying primitive reality is that React compares dependencies by reference, not by content.
Right, so if you don't stabilize the reference in memory, React thinks the data is new on every single render and it just crashes the tab.
Or consider the multi-stage complexity of a C compiler. The source code for Git utilizes a global variable literally named false path compiler does not know it.
I saw that. It's so clever.
Yeah, by defining that variable in a separate compilation unit without a const qualifier, the C compiler is mathematically forced to assume the variable might be true.
Right, which tricks the compiler into suppressing unreachable code warnings during the initial build.
And the brilliance is that it's just a temporary deception.
Yeah, because later in the process, during link time optimization, the linker analyzes the whole program, realizes the variable is always false, and strips the redundant code out entirely.
And an LLM just doesn't intuitively grasp that kind of multi-stage, human-driven compiler deception.
Because it completely lacks the meta context of why a human would want to trick the compiler in the first place.
It is the exact same principle with databases. Like, SQLite vastly improves performance by pre-sorting random data before insertion.
Right, because if you just insert data randomly, it causes B+ tree thrashing.
The database constantly has to rebalance its internal tree structure, splitting pages and just destroying performance.
So human intuition dictates sorting the data first to optimize the primitive data structure.
And human intuition also governs the physical limitations of the terminal. Developers are achieving sub-50 millisecond terminal speeds by manually sourcing plugins and aggressively lazy loading heavy commands.
Because an AI agent doesn't feel the psychological friction of a lagging terminal prompt, right? It will happily just load every command globally.
Exactly. The human engineer configures the system to only load the heavy lifting when it is specifically invoked.
We see these architectural wins everywhere right now. Look at the recent conductor rewrite.
Oh, where they rebuilt a local React app to be twice as fast by understanding system bottlenecks?
Yes. They shimmed the Tory bridge, moved the agent processes to the bun runtime for speed, and shifted the SQLite Git checkpoint entirely off the critical path.
AI generation doesn't just arrive at that conclusion on its own. Human architectural mastery does.
And humans are building really specialized tools to maintain that edge, too.
Like SEM, which provides entity-level Git insights. Or Lathe, which uses LLMs to generate local Golang tutorials so developers can actually learn the primitives.
You also have Clerk CLI providing instant off scaffolding.
And Zero, which functions as this streaming query sync engine that completely bypasses traditional download constraints.
But the necessity of human precision extends way beyond just code optimization. It's critical for identifying systemic blind spots.
Right. The data highlights this recent empirical study on algorithmic monocultures in the hiring process.
Yeah, because a massive percentage of employers are using the exact same few vendor algorithms to screen resumes. The industry is seeing widespread systemic rejections and amplified racial disparities.
And an AI agent analyzing aggregate hiring metrics might completely miss that pattern because the data within its specific silo looks mathematically sound.
Exactly. It requires human position-level analysis across multiple organizations to uncover that the algorithm itself is creating a systemic failure.
The AI generates the output, but the human must verify the reality.
And this tension between the AI's rapid generation capabilities and the absolute necessity for human precision is just colliding with an incredibly unforgiving macroeconomic reality.
Yeah, let's talk about the money. The industry requires trillions of dollars in revenue by 2030 just to justify the current massive expenditure on data centers and GPU clusters.
The AI industry is essentially functioning like a bullet train that has to accelerate infinitely just to keep the lights on.
But major AI labs are missing their projected growth rates.
And enterprise clients are scaling back deployments because the return on investment simply isn't there yet.
So the corporate giants are pivoting aggressively to secure that revenue. OpenAI is reportedly planning a massive overhaul of ChatGPT into a comprehensive super app.
Right. They are attempting to pivot away from a simple chat interface to an ecosystem focused entirely on agents and automated coding tools ahead of their IPO.
But the open source and international competition is closing the gap fast. Models like DeepSeek V4 Pro are now empirically beating GPT 5.5 Pro on precision text tasks.
Yeah, tasks like complex regex correctness and strict adherence to JSON schemas.
Meanwhile, while the massive labs are shoveling capital into the bullet train, Apple is quietly building free train stations to lure indie developers into their ecosystem.
It's a huge strategy shift. At WWDC 2026, Apple introduced a new AI architecture built fundamentally around Google Gemini.
Featuring a system orchestrator that manages context across all your devices.
And they are signaling the hardware to support this with a foldable iPhone Ultra.
But the real strategic masterstroke is the infrastructure offer. They're giving free private cloud compute to any indie developer, with under 2 million app downloads.
By absorbing the massive financial burden of high-tier AI infrastructure, Apple removes the primary barrier to entry for smaller developers.
It is a totally calculated play to win back the grassroots developer support that builds the killer apps necessary for a thriving, long-term ecosystem.
It's brilliant, really.
So the entire landscape is shifting beneath our feet. We've mapped out the mathematical tokenization of LLMs and how it's doubling coding speeds.
We explored that necessary transition toward deterministic agent experiences and the whole workflow of automated doubt.
We've analyzed the severe risks of developer skill decay, the enduring value of human intuition in navigating the quirks of React and Git compilers, and those massive trillion-dollar economic pressures driving this entire evolution.
The tooling will definitely continue to abstract the mundane, and the environments will optimize for machine agents. But the foundational requirement for human architectural vision, the ability to understand the primitive truth of the system, will honestly only become more critical.
Which leaves us with one final lingering thought for you to ponder before you jump back into your code base. If we are shifting our entire workflow to build deterministic agent experiences, and we are heavily relying on automated doubt to have AI models critique the code that other AI models just wrote, what happens when the AI decides that the absolute most efficient system architecture is one that is fundamentally unreadable to the human mind?
Wow.
Yeah.
At what point do we optimize ourselves completely out of the comprehension loop entirely? Something to think about next time you let the autopilot take the wheel.
Spoken Tech for your ears.